We have the same learning goal that we had yesterday, which is we're going to be able to graph and solve a system of linear inequalities into variables. We know that that means we have a system. There's how many? 2 or more. Okay, well, good news is right now we're working with just 2. Sometimes it can be more than that, though. It could grow. So let's look at our system. The last one we have left to solve here on our notes that we started yesterday. Y is greater than 3, or y is greater than or equal to 5x. What do you notice about that first linear inequality? Doesn't have a slope. Okay? Because why?
Because the slope is 0.
Because the slope is 0. How do we know the slope is 0? Is it
Zero.
shouting that out or what?
0 times x is 0.
0 times x is 0, unless there are no x's in it, are there? What kind of a line has a 0 slope?
A vertical line.
Straight.
Okay. Is this a vertical line?
No, it's just horizontal.
Horizontal line? I like the straight. Well, straight. Aren't all lines straight?
Yes.
They better be. Yeah. So, which one of these two, vertical or horizontal, has a slope of 0?
The bottom one.
The horizontal one, right? Yeah. We don't rise any, so our 0's upstairs. We just run. So we have a number downstairs. We have a 0 upstairs. What happens when you have 0 upstairs and you divide by any number other than itself? What do you get?
0.
0. Well, how come we don't say the vertical line has a slope of 0?
Because that's undefined.
This is an undefined slope, isn't it? Why is it undefined?
Because it only goes straight up.
Okay, so what becomes 0 in this one, the rise or the run?
The run.
The run. We don't go left to right. To go from point to point, we just go up and down, don't we? So we have numbers upstairs, but what do we have downstairs?
Nothing.
We have a 0. And can you divide by 0?
No.
No. So a vertical line has an undefined slope, and a horizontal line has a slope of 0. So let's be reminded then, when we have a horizontal line, we don't see what in our equation or inequality? What don't we? We don't see the slope because we don't see the x's. There are no x's for you to see. They've been multiplied out of there because they've been multiplied by 0. What don't we see in a vertical line's equation or inequality? The y is missing. Yeah. So what do we have here? We have a horizontal line, don't we? So let's do these on separate sides here. 4y is greater than or equal to 5x. Okay. So this one right here says, you know what? Right now, who cares about it having a slope of 0? Why do we want to write that down? We're just going to say, oh, it does have it. We do care that it has a slope of 0. It just means that it tells us it's a horizontal line. So we have a horizontal line that has a y-intercept of what? Where's it going to cross the y-axis at? 3. And will it have a dashed line, or would it be a solid line?
Dashed.
It's going to be dashed. And, okay. So let's go ahead. Let's just go graph that then. We only have one point we have to put on here. We have to put that point at positive 3 on the y-axis. And draw ourselves a what? Dash. Horizontal line. A dash. Now, these are the ones that are tricky because they're going to be on top of another grid line. So, press with your pencil and make a very definite dashed boundary line that is horizontal going through that point you just put on your graph. So make sure, extend it beyond. That's what helps. If you extend it beyond and I can see the dashing on the outside, you can see the dashing on the outside, you're like, oh, I guess that's dashed. But if you just keep it contained within the grid that I provided for you, then sometimes you're like, oh, I can't really tell. Okay? And then, we got to decide where to shade.
Above.
So it says y is greater than 3. So you're thinking we should shade above it?
Yes.
So basically it's saying all the y values need to be greater than 3. So it's appearing that we should shade it up here. Could we test something
Yes.
still just to make
0,
sure?
0.
Yeah, we could test 0, 0. We could still do our test point. But are we going to have to sub an x value in? No, because we don't have any x's. So we're going to do y is greater than 3, subbing in a 0 for our y. And we're going to get
It should be false.
true or false.
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 0 is
0 is not greater than 3, which tells us what?
It should be shaded below
It should be in the other, it should be shaded in the part that's not in, right? And that's below. See, this is what we were testing right here. It turned out false. We better shade up here, and we decided that we should. So shade lightly up there. So nothing says boundary lines can't be horizontal lines or vertical lines either, so we have to keep that in mind. Okay, how about our next one now? Is it in sloping set form? It's real close though, isn't it?
Yes.
What do we have to do?
Divide 4 by both sides.
Divide 4 by both sides. I love that line. Put your shoes on and then your socks look around. Does that look a little weird? Divide 4 by both sides. Really? How are we going to say that? Divide both sides by 4. Put your socks on first, but then put your shoes on. Say, order matters in that. You got to talk properly. So we're dividing both sides by 4. Just want you guys to sound like geniuses out there on the street, okay? And then, did I divide by a positive or a negative? So that means we do or don't reverse the symbol. Don't. And what's 5x divided by 4?
5 over 4.
5/4 x, right? Yeah. Okay. Is this a vertical line?
No.
Horizontal line?
No.
Okay, see, here's what happens sometimes when one of them is, then our brain wants to think the other one might be something like that also. This has x's and y's, doesn't it? So what's its slope?
5 over 4x.
5/4. No, there's no x involved in the slope. And the y-intercept is
0.
0. There's nothing being added, right? We don't have to have it there. Should this be a dashed or solid line?
Solid.
Oh, I'm thinking it's solid, yeah. Okay. And should it rise or fall from left to right?
Rise.
It should rise, okay. So go ahead and get your solid boundary line for this one graphed. Oh, we're going to shape this one. Above. Okay, so above is which direction, left or right? Left, okay. Can we test the origin this
No.
time? Why not? That's our favorite, come on.
Actually,
We could, but it's on the line.
But is it going to test where we should be shading?
No.
It's only testing if the line should be solid or dashed, isn't it? So we don't want to test the origin this time. You have to pick a
Go
different point.
1-1.
You could do 1-1. We don't think 1-1 should be in the shaded region though, right? Okay, is it pretty close to the boundary line?
Yes.
You know, I mean, it's probably not going through 1-1, but just to be safe, do you think you should pick one maybe further away?
2-1.
Yeah, sometimes I think you should just get a little bit further away, just in case, you know? So if we checked ordered pair 2-1, which is right here, it should test true or false. What are we thinking? You guys told me you think we should shade here, so it should test false, right? Okay, so let's test it and see what happens. Remember in the original, because, you know, sometimes we rename them improperly and then we think we're right. Did you get 4 is greater than or equal to 10?
Yes.
Is that true?
No.
It's false, isn't it? And that's what we expected. We said, you know what? We already know where we're going to shade, but we're just going to make sure by testing. And we tested it, and sure enough, that is false. So we need to shade on this side of that boundary line. Oh, these get so messy. Oh, you're even shading yourself. Good deal. There you go. And then we say, oh, well, when I look at this graph, somebody else looks at this graph, I need to be able to show them clearly where the solution region is. So make sure you do that right now. What would the solution region, where is the solution region really at? Kind of looking trapezoidal. Isn't it? Oh, you don't think so, Cody? Huh, okay. It's looking, I didn't say it was, I just said it's looking. Okay. So we need the upper left, can't extend beyond, it can't go below that dash one, it's gotta be. But then we also have to be really careful when we're doing that so-called triple shading. We're gonna make sure we don't cover up our boundary lines, because one boundary line is dashed and the other is solid, right? So give me a point from one of the boundary regions. Here's our boundary region right here. I'll use another color yet. I'll make it yellow here. Give me a point from the boundary region that is the boundary, not the shaded, the boundaries that, bound this region. Give me a point that is not a solution.
-2, 1.
Oh, no. Okay, -2, 1. Here's the one that Cody just gave me. Did he do what I wanted him to do?
You said not a solution.
No, I said not a solution that's on the boundary around our shaded region. Noah.
3, -3.
3, -3. 1, 2, 3. No. You don't understand what I meant.
Oh.
Abby? Oh, thank you, Abby. There we go. -3, 3. Why is that not a solution from our boundary region? It's on what kind of a line? Dash line, yeah. If it's on a dash line, it can't be a solution, can it? Okay, now give me one from the, I think we got it now. Give me one from the boundary region. The boundaries around our region that is a solution.
-2.
Ronte.
0, 0. Wait, which one? Like the
Okay, 0, 0. That's right here. Is that on the boundary of my shaded region?
oh that okay.
That yellow? You see this yellow here? Okay. Michaela. 4 or 5. Okay, let's try that one. 1, 2, 3, 4. 1, 2, 3, 4, 5. Right there. That guy right there. Is that a solution to our system?
Yes.
Why?
It's on the boundary.
It's not a solid line. Okay, final question for the $1 million that I do not have. Is this point right here, I just made it green and now I'm going to stick some purple all around it. Is that point right there at the corner of this, this little turn here, is that a solution?
No.
Yes. Because it's on a dotted line and it's near the
It's
shade.
not a solution because it's on the dotted line. But it also is one because it's on the solid line as well. Isn't it?
Well, then we got to make up our mind. It can't be both. It just can't. It's not. Julia says it's not.
It is.
Noah says it is. Oh.
Test it.
Test it. What if we knew what it was? Does it look like it's it has integer values?
No.
Yeah,
It's
that's-
a decimal or a
Yeah,
fraction.
it's probably a decimal or fraction. We probably would have to estimate what we think it is and test it that way, and that would be hard. So we're going to have to use some other reasoning because testing isn't going to work.
Well, it's on a solid line and it's close to the shade.
Okay. So can I just draw the picture over here? We got this solid line. We got this dash line going through it, and the point I'm talking about is right here. So it is or it is not a solution.
It isn't a solution.
All in favor of it is? Probably raise your hand.
Really? Really?
You could be right. Sometimes lone survivors are the ones that are right. They're just bold enough to speak up and then they get rewarded. Okay, how about it is not? Oh, and then I got some people who are like, I don't want to know. That's kind of how I know about presidential elections here. You got to vote. Take a stand, Calvin. Which one do you want?
I don't know, so.
Oh,
Just pick one.
Then pick one, yeah, just
Is
pick
there
one.
a-
That's what I'm gonna do.
Which
I'm
one?
gonna pull it, just gonna pick one. That's what's gonna happen. It is not a solution. If, what would make it a solution?
If it was on a solid.
If this one was solid also. It would satisfy this inequality, it would not satisfy that inequality. They're working together, they're pals, you can't, one can't work without the other, so it is not. Watch out for those trick questions on the quiz. Okay, anybody have any questions? Any trick questions for me? Okay, let's go to work on our homework. Get out a sheet of loose leaf paper.